Now does you have the characteristic? We are going to discover the characteristics. Right. For functions of the general form f at theta equals y, which is equals to the tan of theta plus p. The domain and range. Now, the domain of one branch. Come on, someone, one piece, because I tell you we born into two equal parts if we are looking at minus 180 and 180. The domain of one branch is what? Theta, such that theta is an element between minus 180 minus p, lay 90 minus p. This is how you find the domain. Why? Because the functions, this is because the function is undefined. This is because the function is undefined for theta equals minus 90 minus p and theta equals 90 minus p. This is exactly what we are saying. This is how you find the domain. The domain of one branch is a theta such that theta is an element between minus 90 minus p and 90 minus p, because the function is undefined for theta equals minus 90 minus p and theta equals 90 minus p. This is just how you find the domain. And then what about the range? The range is f at theta such that f at theta is an element of real numbers. It is defined at every interval in the range, in the y-axis. So this is just something that you should know. Right. And then let us try to look at sketching the tangent graphs of the following form. So we will be looking at sketching the tangent graphs. Tsefi. Mohlomong re ka re ho wena sketch the graph of y equals 1/2 the tan of theta minus 30 degrees. I think you understand this. For minus 180 degrees less or equals to theta less or equals to 180. I think you understand this. We know the effect of A. Again, A.
Up and down. It's vertical translation, and then that one is horizontal translation.
Again, so we know the effect of A. Or okay, if A is between 0 and 1, whether the period of the function again, whether the period increase or whether the period decrease. We dealt with many scenarios, not in fact the period, because K it determines what the period. Again, K A ibuaga A is whether the function here how how do sketch the graph of y equals 1/2 the tan of theta minus 30 for minus 180 and 180 degrees. Now, I'm going to step Step 1. We must examine the form of the equation that is provided. We examine the form of the equation. Right. Rabona for k that is between 0 and 1. Very, very important. For k that is between 0 and 1, the branches of the graph are less steep. The branches of the graph are less steep. And for p that is negative, the graph shifts to the right on the x-axis. The graph shifts to the right on the x-axis. For k that is between 0 and 1. Give me a value when I k. 1/2. Okay? In between 0 and 1.
The branches of the graph are steep, are less steep.
Or for k that is between 0 and 1, the branches of the graph are less steep. That's what we are saying. And then for p that is less than 0, so come on to p, k. The graph shifts to the right on the x-axis. That is exactly what we have looked at previously. Right. Sereboni k, sereboni p na kebukai. Step 2. We determine the period. We determine the period. Right. The period. The period of f at theta equals the tan of 1/2. Man, get all in tuna ham, man. As in tuna ig. Askis, get the tan of 1/2. Askis. I say 1/2 10 because that's what like a. A you will like amplitude function askis. Get the tan of 1/2 theta minus 30. I'm very, very sorry. Man. K between 0 and 1. But you know where the value of A is 1/2. There's a problem. No, the value of K is 1/2. I'm sorry. I want to copy it wrong. The period of f at theta equals the tan of tan 1/2 theta minus 30 degrees is 180 divided by the absolute value of K. 180 divided by 1/2. 360. Period. So period increase. The period of the function increases if the value of K is between 0 and 1.
The range is -60 to 360.
Domain range. Domain range. So the range will always be f at theta such that f at theta is an element of real numbers because they are two positive infinity and negative infinity. Y is an element of real numbers, but that is how you determine the domain. Mona, this is how you determine the range for those two branches. The domain of one branch is this, the first one and the second one, because the function is undefined for theta is between minus 90 minus p and the 90 minus p. Minus 90 minus p, 90 minus p. P, get the value of this angle. A. It's theta plus or minus p. P horizontal shift. whether to the left by certain degrees or to the right. So how many da? I want to step 2. With the period. Rabona, the period of the function as it. Oh, and right. And then from there, step 3. Mobile the asymptotes. These are the procedural methods that one should apply whenever you are dealing with these things. Now, step 3, the asymptotes. We determine the period mona. Step 1, we examine the type of the equation that is provided. And then step 3, we determine the asymptotes. We determine the asymptotes. The standard tangent function. Rather for a standard one, y equals tan theta. Rather for theta, that is between minus 180 and 180 degrees. Rather it is undefined for theta equals minus 90 and 90. Rather for this, it is undefined. For theta equals minus 90 degrees and 90 degrees. Theta equals 90. We know that. Therefore, we can determine the asymptote of f at theta. Regarding the asymptote of f at theta equals the tan of 1/2 theta minus 30 degrees. Or minus 90 over 0.5 plus 30. This is how you do it. Munna, this is very important. Munna, this is highly and highly important. How about the asymptote of this function? Or a 90 or a minus 90. Minus 90 divided by 0.5. It's 0.5 you see. I'll share it one. Or minus 90 divided by 0.5 plus 30. You offer asymptote to your